Next 2-week project, I am doing it on air conditioning. This is a mini fridge, and it's practically the exact same thing as an air conditioner. This is the compressor. This is the copper tubing. That's where you put the refrigerant in. That's the liquid line. Also copper tubing. That's the liquid line. That's the suction line. And then the compressor compresses it and also circulates it. There are your ground wires. There's the electrical for the compressor. Inside, you'll have the evaporator, but that would usually it would usually have fins and copper tubing. But since this is a mini fridge without a blower, you have it like that. But that's a blower. Now, we got our air conditioner replaced recently, and this is what a blower looks like. You have, this is the thing that circulates the air in your house. You have these little metal things, I don't know what they're called, and they like reflect the air, and whenever you spin it, you can feel the air come out. This is very dusty, but also another thing to mention about an air conditioner is that it has AC, not DC, not direct current. That's the motor. So, normally on a normal air conditioner you would have a condenser, which is almost the exact thing as it's usually the exact same thing as a condenser, an evaporator, but it's literally an evaporator outside to get rid of the heat from the refrigerant. Now, if you have a compressor and the condenser fan motor is not running, it will kill the compressor because this is just one big giant motor. You have pistons in here that compress it, and so you have the gas, and then it turns into a liquid when it's compressed, and then it goes to your evaporator up here, and then it goes through the expansion valve, which this doesn't have an expansion valve, so it has like a little spray nozzle, which then evaporates it into a gas, and then it goes back into the compressor, and then it does that on a constant loop. So this is my furnace at my house. This is the gas vent, but it's not on heating, it's on air conditioning. And this is where the evaporator is. So it goes like an A shape, and the wind gets pushed from the blower through the heat exchangers into the evaporator, and then it goes through your ductwork in your house. Now this is the return vent, this is the supply. This is your gas vent. This is, I suppose I can do a little bit on heating. Hang on a minute. So this is what it looks like inside the furnace part of it. It's just a gas. So pretty much, this is your gas valve. The gas valve opens, and then gas gets spewed out through these things, and then it goes to get enlarged, and then it goes into those little metal pipes, which is the heat exchanger. And this thing right here is this white thing is the igniter. That's the flame sensor. That's safety. And this is your draft motor to get rid of the carbon monoxide. And it goes out through your gas vent into outside. And that's the exact same thing with the water heater. So that's your gas intake. It goes through the gas valve here. It's ignited, and then it heats up the heat exchanger. And yeah, that's pretty much how a heater works. Now a heat pump works as if you literally have this as your condenser for the inside, and then your evaporator would be on the outside, which is the normal condenser in air conditioning mode. So this was for health and wellness. An evaporative cooler works. We have one at school. That's how we get air conditioned and heated at school. But an evaporative cooler doesn't have any of this. Well, it does, but on the original type, you had water that would drip down. That you would have a foam pad, and then water would drip down, and it would be chilled water, and then you would have like a little condenser outside, but not a condenser. It would cool off the water, and then you would have it run through the system, and then you would have a fan. That's how an evaporative cooler works. That's pretty much all the types of air conditioning, but on newer air conditioners, on newer evaporative coolers, you would have the chiller outside, which is the big cooling tower, which is nicknamed Marley at school. It chills the water, and all the individual units throughout the building are the actual air conditioners, and they have a compressor and refrigerant and everything because the water cools off. I don't know exactly how the new ones work, but I am assuming that the newer ones have a like evaporator through the water pipe, and then it would heat up the water just a little bit, and then you would have the compressor that would run from the gas to the liquid, and you know the thing. And yeah, that's pretty much how the newer evaporative coolers work. So yeah, that's really my project. Alright, if you don't have like enough money to afford a window air conditioner, this is what you can do. You can take this thing off and have a little fan inside of here, and then turn it on. So then you would have nice cool air coming out. So I don't know if you can see this, but right here is the evaporator, where the refrigerant gets evaporated, and it goes through, this would usually be copper tubing, it goes through this channel system, and this thing gets icy. Originally in 1915, the original guy who invented air conditioning was named Carrier. He invented the first air conditioner, and it originally was a dehumidifier. That's what the side effect was of it. And by like 1950, most mid-class people would have an air conditioner in their house. And yeah, that's pretty much how an air conditioner works. So just to summarize, you have heat from inside, it gets moved outside through refrigerant. That's it. That's that simple, honestly. So yeah, that's how you would make a homemade air conditioner. Well, not really homemade, but a